Hello everyone, Assalamu alaikum. Welcome to the new lecture on pharmaceutical chemistry. This is me Faraz Qurban Rajpar, and in this video lecture I am going to discuss with you about the Diels-Alder reaction. Diels-Alder reaction is one of the most important organic chemical reaction that was discovered by Otto Diels and Kurt Elder in 1928. For this Nobel achievement, they have been awarded with the Nobel Prize in the field of chemistry in 1950. So now let's discuss about what is basically the Diels-Alder reaction is, which type of reactant are used, and what will be the main product of Diels-Alder reaction. A Diels-Alder reaction is basically a type of cycloaddition reaction that occurs between a diene and a conjugated molecule that is mostly alkene, and it can be any other unsaturated compound, but the requirement for that is having the pi bonds. It can be alkyne or it can be a cyclo unsaturated compound, and that molecule is known as the dienophile. So basically it is the cycloaddition reaction between a diene and a dienophile, and this reaction results in the product that is the cyclohexene ring. This is known as the cycloaddition because the addition reaction in this occurs in the cyclic manner. The process, let's discuss about the explanation or the other parameters that what is happening in the Diels-Alder reaction. Basically the transformation or the movement of electron or bonds is occurring in the cyclic friction in this reaction. That's why it is known as the cycloaddition reaction. And the product that is formed is the cyclohexene, that is also a cyclic structure. Diels-Alder reaction is classified as a pericyclic reaction because the cycloaddition or the movement of electron that is occurring in the cyclic friction is occurring only in a single step mechanism, and the stereochemistry of the structure has been retained during this cyclic process. So that's why they are the pericyclic reaction. Diels-Alder reaction are the concerted and stereospecific. Concerted means the reaction is occurring in the single step. Clear means they do not require the multi-step. The single step transitional stage is also occurring in the same single stage of the reaction, and the reaction is the stereospecific because there is a certain requirement of the stereochemistry for the Diels-Alder reaction. For example, the reaction is only favorable if our diene molecule has the S-CIS conformation. We will discuss later on the reason behind the stereochemistry. The Diels-Alder reaction is occurring in the single step. That's why the concentrate and the resultant product is a 6-member cyclohexene ring. So basically what we have learned that there are the main two components for the Diels-Alder reaction. One is the diene. Diene is basically the conjugated compound or the conjugated molecule that is required for the Diels-Alder reaction. So these are the different examples of diene molecule that can be useful for the Diels-Alder reaction. Like this is the 1,3-butadiene, this is the 2-methyl-1,3-butadiene, this is cyclohexadiene, cyclopentadiene, and cyclohexadiene molecule with the additional carbonyl or the other groups that have been substituted in the ring. So the main requirement for the diene molecule that it must be conjugated. The second component is the dienophile. Dienophile means the diene loving, means it is that molecule which is going to be attack our diene molecule in order to form the cyclic ring structure, that is the cyclohexene. For the dienophile, the requirement is it must have at least one pi bond. and that pi bond can be in the form of double bond like the alkene ethene are the alkyne, are the compound that is having the triple bond. So these are the different example of the dienophile. You may observe that these are the ketone, this is the ethene molecule, and substituted with the cyanide. Again, this is the being substituted with the ester, and this is the cyclic dienophile molecule. So these all are the different example of basically the dienophile, which are going to be reacted with the diene molecule. You may observe that there is the substitution in the dienophile molecule. We will discuss in the later on that what it will be the effect of the substituent in the dienophile structure. So now let's discuss about the general reaction and the reaction mechanism of the Diels-Alder reaction. So as I have previously told you that it is the Diels-Alder reaction is the reaction that occurs between a diene and a dienophile molecule. A diene is basically the unsaturated conjugated molecule which have at least the 2 pi bond, and a dienophile is which is going to be attack our diene molecule. So in the end, the resultant of this reaction will be a 6-member ring which have the 1 pi bond. So this is the general reaction mechanism. Over here the example is shown of the 1,3-butadiene, because you may observe that the double bond is present at the 1 and 4th number carbon, 3rd number carbon, and when it is going to be react with the ethene molecule, this is the ethene, then it will result in the formation of the cyclohexene which have the 1 pi bond. So basically what is happening in the reaction, the cyclic transformation of the pi bond and the breaking of pi bond and the formation of the new sigma bond occurs in the cyclification. How it is going to be occur, we will observe in the reaction mechanism. So basically the new bonds which will be formed between the carbon number 1 and 6. Over here this double bond of ethene will shift to this carbon number 1. So this is the newly formed sigma bond, and this pi bond which is present between the carbon number 1 and 2 will shift between the carbon number 2 and 3. So this will be a newly formed pi bond between the 2 and 3 number carbon, and again this double bond which is present between carbon number 3 and 4 will shift to the 4 and 5 number carbon. So again this will be a new sigma bond form. Now let's observe that which bonds are broken. This pi bond which is between the carbon number 1 and 2 is going to be broken, and again this 3 and 4 carbon bond is again broken, and this. So overall there are 3 pi bonds which are going to be break down during this reaction. So this is the general reaction mechanism for all the Diels-Alder reaction compound. You may observe that the 2 new sigma bonds are formed during this entire reaction mechanism, and the total 3 pi bonds are going to be break down, and out of these 3 pi bond, basically 2 are being converted into the sigma bond, and 1 is just shifted from one position to the other. So now let's observe the reaction mechanism for the Diels-Alder. So this is the reaction mechanism for Diels-Alder reaction. You may observe or you may draw the movement of electron either in the clockwise or the anti-clockwise manner. So let's have a look at this clockwise manner transformation. For suppose this is the 1,3-butadiene molecule, it is going to be reacted with the ethene. Over here this 1,3-butadiene is a diene molecule, ethene is acting as a dienophile. Now they are going to be reacted. So what is happening, basically this double bond which is present between 1 and 2 is going to be break down, and it is going to be transferred at this, and it will form sigma bond with the carbon 1 and 6. Clear? And now this double bond which is present between the 3 and 4 is going to be shift down between the carbon number 2 and 3. Clear? And this double bond which is present between carbon number 5 and 6, will be break down and it will come and form a sigma bond with between carbon number 4 and 5. So overall what we have observed that the pi bond is which is going to be break down between carbon number 1 and 2, it will ultimately form the sigma bond or single bond between carbon number 1 and 6, and other pi bond that is present between carbon number 5 and 6 has been broken down and it will form the sigma bond between carbon number 4 and 5, and the third pi bond which is present at the 4 and 5 carbon, it will be shifted and form the double bond or the pi bond between carbon number 2 and 3. So overall this newly formed molecule will be known as the cyclohexene. These blue lines are representing the newly formed bond in the chemical structure. So overall in the product 2 new sigma bonds have been formed and 1 pi bond have been formed. That 1 pi bond is basically just the transformation of the already present pi bond in our diene molecule. So this same this cyclic transformation of electron can also be represented in this form, that is the anti-clockwise manner, like here you may observe that this 1 2 is going to be shifted between the 2 and 3 carbon, this 3 and 4 pi bond is shifted and form a new sigma bond between 4 and 5 carbon, and likewise this 5 and 6 pi bond is going to be break down and form a single sigma bond between carbon number 1 and 6. So overall what we have observed that in the Diels-Alder reaction this general pattern will be repeated, that the 3 new pi bond 3 pi bonds have been broken down in the reaction, and out of which 2 are converted into the sigma bond and 1 new pi bond have been formed. So this is example is shown with the between the 1,3-butadiene, that is the diene molecule, and our dienophile was the ethine, or what we say the ethene or acetylene. Now let's discuss the same example of the Diels-Alder reaction by considering the 1,3-butadiene, and our dienophile over here is the alkyne. So you may observe that in alkyne we have the triple bond. So the same shifting of the bond and the breaking of bond will occur, that this bond will transform at this position, clear, over here, and this carbon number 3 and 4 double bond will shift and form a single bond over here with this carbon, and this double bond will shift and form a bond here. But over here, as we have the 3 bond or the triple bond, so we have an additional pi bond in our resultant product. So you may observe this resultant molecule have the 2 pi bond and the structure is known as the cyclohexadiene. So since the reaction is occurring in the cyclic transformation, so the cyclic transition state, and that's why it is the cycloaddition. So this is for your understanding. The movement of electron has been shown in case of the 1,3-butadiene, and this is the 1,3-butadiene reaction with the ethine, that is a triple bond. So this bond has been shifted here, this double bond is shifted and form the new sigma bond over here, and this double or pi bond has been break down and form the sigma bond over here. So resultant product is the cyclohexadiene. Now let's discuss what are the main conditions, or what we say the requirements, or the main parameters or characteristics of the Diels-Alder reaction. So there are the certain conditions or characteristics that are important for the Diels-Alder reaction, and without these conditions the Diels-Alder reaction will not occur. First of all, the first important characteristic is the diene must be conjugated. Number 2, the diene must be in S-CIS conformation. Number 3, the substituent that are present or that are going to be substituted in the structure of where the diene or dienophile do not change the pattern of bond forms or broken, means they will not affect the product cyclic structure. Number 4, but the substituent can affect the rate of reaction. means the substituent can either enhance the or decrease the rate of chemical reaction or formation of product. So number one condition is our diene must be conjugated, means the diene which we have already discussed in our previous example was the 1,3-butadiene. We may use an other diene molecule, but the condition that it must be conjugated. Conjugated means our diene must have, or our molecule must have, at least 2 pi bond that must be present alternate with the single bond or the sigma bond. So that is the conjugation which must be present in diene. If the conjugation is not present in the diene molecule, then Diels-Alder reaction will not occur. So for example, we have discussed that 1,3-butadiene can easily undergo through the Diels-Alder reaction because it contains the alternate single and double bond. But over here another example is given, that is the 1,4-pentadiene. It will not undergo through the Diels-Alder reaction. Now the question is why the 1,4-pentadiene is not going through the Diels-Alder reaction. So over here you may observe that this is the chemical structure of 1,4-pentadiene. In this structure you may observe that conjugation is absent. Conjugation is basically a terminology used in the organic chemistry that these double bond or unsaturation must be present alternate position with the sigma bond. So in this structure you may observe that conjugation is absent. Over here we have the double bond, over here single bond, and again another single bond, and then double bond. For conjugation over here with double, single, and then over here we must have the pi bond. But in this case, in case of 1,4-pentadiene, 2 consecutive sigma bonds are present, and that's why conjugation is absent. So that's why over this molecule 1,4-pentadiene cannot undergo through the Diels-Alder reaction with any type of dienophile. So that's why no reaction is occurring. So the condition is our diene molecule must be conjugated. Next condition or characteristic of the Diels-Alder reaction is our diene molecule must be in S-CIS conformation. S-CIS conformation means the single bond cis conformation. So let's discuss why this condition is important, because the 2 carbon-carbon pi bond that are going to be formed must adopt a conformation where they are in the same plane. It means the flat pattern. So our diene molecule must adopt such conformation that they are oriented in the cis conformation central to the sigma bond in the product in order to have the Diels-Alder reaction. So they must have the S-CIS conformation, means they do not have the S-trans conformation. Our diene must have the S-CIS conformation. Now let's check out that why it is important for a diene molecule to have the S-CIS conformation and why the S-trans conformation cannot undergo through the Diels-Alder reaction. Because our S-CIS conformation, they are in the same plane, so they can easily undergo through the Diels-Alder reaction. So you may observe that this S-CIS conformation is the reactive for the dienophile. They can easily react and form the product. On the other hand, S-trans conformation is highly stable. It cannot undergo, it cannot form the reaction with the dienophile. Why it is happening so? It is occurring because of the geometry of the molecule. In the S-trans conformation, that is the single trans conformation, you may observe this is the they are present in the opposite plane. This double bond over here, we have this double bond. So they do not undergo through Diels-Alder reaction because there is the huge distance or the bond angle between these 2 unsaturated double bond. On the other hand, S-CIS conformation can easily undergo because they are in the same plane, and the bond distance is not that far apart. So this molecule can easily undergo through the reaction. You may observe that the bond length between the 1,3-butadiene that is in S-CIS conformation is the 1.33 angstrom. On the other hand, the 1,3-butadiene molecule which is in S-trans conformation has the bond length of about the 3.7 angstrom, which is huge in comparison to the S-cis conformation. So that's why these molecules that are in the S-trans conformation cannot be bridged by the dienophile, means they are not going to be easily undergo through the reaction with the dienophile, and they do not result in the cyclohexene product, that is the product of the Diels-Alder reaction. So the Diels-Alder reaction, we have observed that for the molecule to undergo through the Diels-Alder reaction, our diene must be in the S-cis conformation. Number third condition is the substituent molecule that are going to be substituted on the diene or dienophile do not affect the bond forming or bond breaking pattern of the Diels-Alder reaction. This is indicating what? The substituent molecule that can be electron donating group, that can be electron withdrawing group, which are going to be substituted on whether diene or dienophile. They do not have any effect. They do not affect the bond forming, bond breaking process of our resultant product. Clear? So how this is happening? For example, let's check out if the methyl group is going to be substituted in the structure of 1,3-butadiene. Clear? So we may observe our resultant product will be the 1-methyl cyclohexene. Clear? Means the reaction will occur in the same manner. In the same manner, the bond breaking and bond shifting is occurring, but in the product we have additional methyl group at this same geometry on the carbon number 1. So this does not have any effect on the bond forming or bond breaking, means it does not have any effect on the geometry of our resultant product. In the same way, if we are going to substitute any of the molecule like methyl, that is the electron donating group, in our dienophile, again it will not have any effect on the geometry of the resultant product, that is the cyclohexene. It will acquire the same place in the resultant product. Like over here you may observe that additional methyl group is present in the cyclohexene structure. Now the fourth condition is the substituent, which we have already discussed, that if we are going to substitute in the diene or dienophile, we can have the effect on the rate of reaction, means they can either speed up or speed down the rate of formation of the product, that is the cyclohexene. Now let's check out how they are going to speed up or slow down the Diels-Alder reaction. So basically there are the two type of functional group. Some are the electron withdrawing groups that are going to take the electron away from a molecule, or what we say, they are going to decrease the electron density of a molecule. Like the examples are the carbonyl containing compound, the electronegative atom, fluorine, chlorine, and many other examples like ketone, esters, and nitrile are acting as the electron withdrawing group. And some are the electron donating group. They are the alkyl alkoxy group or the methyl group. These are the electron donating group. So when we are going to substitute these molecules in any compound, they are either going to increase the electron density or decrease the electron density. So for the Diels-Alder reaction to occur in a good way or to occur smoothly, we must substitute electron withdrawing group in our dienophile, because our dienophile are going to act as the electrophilic center, because they are going to act as the electrophilic. Dienophile are themselves what we say in this reaction are occurring as the electrophile. So with the dienophile electron, if we are going to substitute electron withdrawing group like aldehyde, ketone, esters or nitriles, then the Diels-Alder reaction can occur with a good speed. On the other hand, if electron donating group are going to be substituted in the dienophile, clear, in the dienophile, if we are going to substitute electron donating group, then the reaction will not occur smoothly. Clear, because our dienophile is already the electrophilic, it requires the electron, and if we are going to substitute with the electron donating group, again the electron donating group will going to be decrease the density. So that's why the dienophile cannot undergo smoothly through the reaction. So this is the opposite case. Now the electron donating group, on the other end, if we are going to substitute these electron donating on the diene molecule, then our reaction rate can be increased. So what we have learned, that we may increase the rate of our Diels-Alder reaction by substituting electron withdrawing group on the dienophile, because our dienophile is the electrophilic, it requires more and more electron, and the electron donors on the diene. Clear. So the electron donors group, which group, that are the alkyl alkoxy. In that manner our rate of reaction can be enhanced. For example, if we are going to substitute the one of the hydrogen in the ethene with the electron withdrawing group, say suppose the cyanide, in our what we say dienophile, then the resultant rate of reaction will enhance with 10 to 5 times. So let's observe that the different other electron withdrawing functional group that can accelerate the rate of reaction by substituting in the dienophile. Like this one is the example of the ester that is being substituted in the dienophile, that is the ethene. You may observe that reaction rate has been enhanced, and in the product we have the same type of the CO2Me functional group. Clear. So electron withdrawing group must be substituted on the dienophile, and electron donating group must be substituted on the diene in order to have achieve the optimum product in the with a good speed. So now let's discuss about the different examples of the compounds which are undergoing through the Diels-Alder reaction. So up to now we have discussed the examples of the simple aliphatic or the without cyclic chain diene and dienophile. But our diene and dienophile can again be the cyclic structure, means that they can be the cyclic compound. So let's discuss the example of the cyclic diene. This is the example of 1,3-cyclopentadiene. Clear. Now when it is going to react with the dienophile, that is the ethene, again a new product will be formed. But over here we must understand the geometry of the resultant product. It is basically occurring in the same fashion. There is a trick for understanding its structure. The same bond breaking and bond formation will occur, means our resultant product will be the cyclohexene. Clear. Like over here the cyclohexene. You have to only focus on understanding that how this bond forming and breaking is occurring. So for suppose let's you consider this carbon 1 2 3 4. Clear. This is 4, and now this one is 5 and 6. So what you have to do, you have to keep this carbon or what we say methyl group same as it is. Clear. You have to shift, you just shift this double bond over here 2 and 3, and this double bond will form the new sigma bond with the carbon number 4 5. Okay, so new double bond, single bond will be formed between carbon number 4 and 5, and again this bond will be shifted and form sigma bond between 1 and 6. Clear? And this methyl group will remain same inside the cyclohexene structure, like that, like over here shown in the product. The same cyclohexene structure is being formed by the breaking and formation of new sigma and pi bond, and this methyl group will remain inside as a carbon number 7 in the structure. Clear? So this will be the resultant product for the Diels-Alder reaction of the cyclic compound that is going through the Diels-Alder reaction whenever diene is cyclic and dienophile is the same molecule like the acyclic. So you may observe the same pattern of bond formation and bond breaking has been occurring in this, like the bond is being formed between carbon number 1 and 6. Yes, bond is being new pi bond is being formed between carbon number 2 and 3, and new sigma bond between 4 and 5. Yes, and bond breaking, like the 3 pi bonds have been broken down between carbon number 1 and 2. Yes, it is occurring, and between 3 and 4, yes, the same pi bond has been broken, and the pi bond between 5 and 6 has been broken down. This methyl group will form a new position inside this cyclic structure. Clear? So I hope you must have understood now that how the cyclic diene will undergo through the Diels-Alder reaction. There is another example of the cyclic diene molecule, like this one is the 1,3-cyclohexadiene. This is the hexadiene compound. When it undergoes through the dienophile reaction with the dienophile, what will be the resultant product? Our resultant product will have the structure like this. Clear? Now how is it is occurring? The same pattern which we have used in the previous reaction, like this bond will be shifted and form the double bond over here. Okay, you have to mention numbering like this: 1 2 3 4. Keep this 7 and 8 carbon 7 and 8 carbon, keep it same as it is. Clear? You have to remember the pattern of bond formation between 1 and 6, 4 and 5. Clear? Our 5 and 6 carbon will be this dienophile. Then you can draw easily the structure of your resultant product easily. Clear? So let's form a bond between 1 and 6. Yes, we have formed the 1 and 6, and 4 and 5. Yes, 4 and 5. How? Between 4 and 5 by the breaking of this pi bond, and between 1 and 6 by the breaking of this dienophile double bond. Clear? So now this carbon, this methyl group, that are the 2 carbon, will form the position inside the ring. 1 2 3. You may observe this is 1 2 3. This will form the position inside the cyclohexene. Clear? So you may observe that the same type of bond are being formed between carbon 1 and 6, 2 and 3 inside our cyclohexene resultant product 4 and 5, and same bond breaking pattern is occurring in this reaction. You can also draw the structure and like in this manner, but this is easy for you to draw in this way. This is the 3D representation of this resultant cyclohexene molecule in the 3D pattern. So now let's discuss another example. What will be the product is if our dienophile means which is going to be reacted with the diene. If our dienophile is cyclic, this is quite easier than in the case of diene is in the cyclic. Clear? So let's consider this is the diene molecule, that is the 1,3-butadiene. Clear? This is acyclic, but in this case dienophile is the cyclic compound, that is the malic anhydride, that is the malic acid anhydride. Okay, when it undergo through the Diels-Alder reaction, it will form the same position in the product, like over here you may observe this bond is going to be shifted over here. This 4th carbon pi bond will break down and form a sigma bond with this. Clear? This double bond, that is the pi bond which is present between carbon number 5 and 6, will form sigma bond at here, and this region or this portion of the structure of maleic anhydride will remain same and form the same position in the resultant product. Like you may observe, this will be the product of this reaction when 1,3-butadiene is going to be reacted with the maleic anhydride. Structure of the resultant product will be look like this: cyclohexene molecule, and the remaining portion will be of the maleic anhydride that is being attached or bonded with the product. If you may observe the bond formation and bond breaking pattern, it is again remains same. Let's check out that 3 pi bonds have been broken down, which between carbon number 1 and 2. Yes, we do not have any of the pi bond between 1 and 2. Between 3 and 4, yes, 3 and 4, we do not have any pi bond between 3 and 4. Yes, it is going to be breakdown. And we do not have any pi bond between carbon number 5 and 6. And yes, the double bond is absent between carbon number 5 and 6. And you may observe the same pattern of the bond formation, like the newly formed sigma bond is formed between carbon number 1 and 6. Yes, over here it was absent, and new bond has been formed between carbon 1 and 6, and the new pi bond between 2 and 3 and 4 and 5. Yes, it is occurring. So this is the example when the Diels-Alder reaction is occurring between conjugated diene and our dienophile is in this cyclic structure, that is the maleic anhydride in this example. So now let's discuss another dienophile example, that is the cyclic. Clear? So over here we have the 4-methyl 1,2,4-triazolene 3,5-dione. This is the dienophile. This is again the cyclic structure. You have just to remember the same pattern of the how the 3 double bond or the pi bond are going to be break down, and how new sigma bond where are going to be formed in order to form the cyclic hexene structure. The new double bond, single bond will be formed between 1 and 6 and 4 and 5. In this way you may have the new cyclic structure like this. Clear? And this entire structure will remain same and acquire the same position in the cyclohexene structure. So this will be the resultant product when our diene, that is the 1,3-butadiene, will be reacted with the methyl 1,2,4-triazolene dione. Clear? And over here you may observe the same pattern of bond formation between carbon 1 and the 6th position we have the nitrogen. So that's why it is representing here the nitrogen in place of the carbon C1 and C6. You may observe the same type of bond new is being that is the pi bond be formed between carbon number 2 and 3 and 4 and 5. So for Diels-Alder reaction, bond formation and breaking will same in any of the diene or dienophile, whether it is cyclic or acyclic. So in this reaction you may observe that there is a heteroatom, that is the nitrogen. So whenever we are dealing with the Diels-Alder reaction that have the heteroatom in their structure, then in that case the Diels-Alder reactions are termed as the hetero-Diels-Alder reaction. Heteroatom is that atom that is other than the carbon and hydrogen. Clear? So that is the nitrogen. In this case it can be sulfur, oxygen. Clear? So over here our nitrogen is part of the cyclic structure. So in those cases the Diels-Alder reaction will be termed as the hetero-Diels-Alder reaction. Applications of Diels-Alder reaction. So this was all about the general reaction, different characteristic conditions of Diels-Alder reaction, and the detailed reaction mechanism, that how bond formation and bond breaking is occurring in Diels-Alder reaction. Now let's check out why this Diels-Alder reaction is important in the field of like the pharmaceutical chemistry. Like it is the main industrial production of the different type of compounds, cyclohexene, cyclohexadiene, cyclopentadiene, that can be useful for the production of the various biological molecules. Like one of the well-known application for Diels-Alder reaction is the synthesis of the vitamin B6. Clear? So now these are the different examples of the Diels-Alder reaction. You have to do this for your practice. So practice these different type of diene and dienophile reaction, and observe that what will be the product. We have already discussed this first question in our this lecture, that what will be the product when the 1,3-butadiene is going to be reacted with the ethene. So you may draw the product of these 2, 3, 4, 5 and the 6 question in your copy for your practice. So these all will be the part of your exam. So this was all about the Diels-Alder reaction. Now you have to attempt the quiz in your comment section. The quiz are given in the description section. Thank you very much. Allah Hafiz.